Hello, I wanted to help you out a little bit with your fractions. I heard it was kind of a little frustrating for you. I hope that you're feeling better and can't wait to see you when you get back. So, equivalent fractions. The key to equivalent fractions is that there's the part of the word equal in it. It sounds kind of like equal when you say equivalent fractions. So, this first part that I assigned to you, we had to decide if they were true or false, if they were equivalent. So the first one has denominators that are the same. So that one's pretty, straightforward as far as figuring out if they are, equivalent or not. Obviously, because they're both 8s, we just need to look at the numerators on the top. And one's a 4 and one's a 7, so that means that they are not equivalent. So we are going to make that one false. Hang on, I wanted to use a marker or something. See if it'll let me do it. There we go. False. Okay, this is where it gets tricky. We need to decide if this is equivalent or not. One's put into fourths and one's put into eighths. So we know we have a couple of different strategies in our toolbox that we can use. We can either draw a number line or we could draw pieces. I'm going to stick with the good old number line. Oops, maybe make it look like a line. Yep. That's not exactly a straight number line, but we can use our imaginations, right? So here's 0, and here's 1. So I need to figure out 3/4 first. I think that would be the easiest. So if I break this line into 2 parts and then 4 parts, that gives me, we count the spaces in between, right? 1, 2, 3, and then that would be 4. Yep, so this would be 3/4 right here. So now I have this fraction over here, 6/8. I need to figure out if I gave you 3/4 of a candy bar, if that's the same as giving you 6/8. I know that having the 8s means that my candy bar is broken into more pieces. So let's go ahead and figure out where 8s would be. So we broke this into fourths. In order to break it into 8s, that means we're going to have to break it into more pieces. Looking at 4 and looking at 8, I noticed that they are multiples of each other. Well, 4 is a multiple of 8, and 4 is a factor of 8. So they should work pretty well together. So let me see. If I break this into 8 pieces, let's see if that was right. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, goody. So now I have to count 6/8. 1, 2, 3, 4, 5, 6. Ooh, so this is 6/8. So yes, they are equivalent. If I broke a candy bar into 4 pieces and gave you 3 of the 4 pieces, or if that candy bar the same size was broken into 8 pieces and I gave you 6, you would pretty much have the same chunk of a candy bar. It's just one's broken into more pieces than the other. Okay, this one right here, we have 2 6 and we have 2 8s. The numerators are the top number and they're the same. The bottom number, though, is different. I know that the larger the number is for a denominator, that means there's more pieces. We had talked in class about if you asked a kindergartner if they'd rather have 2 of something or 3 of something, they would always pick the higher number. But that's not the case with fractions. When the denominator is larger, that means it's actually a smaller piece. So because you're giving the same amount of pieces, you're giving 2 pieces, but one of the fractions is kind of 6 pieces, and the other fraction is broken into 8 pieces, they're not going to be equivalent. You're going to get 2 pieces, but they're not going to be the same size. So that one's false. That one was true. Okay, and then this last one, one's a 2 and one's a 3. Let me think about this, though. The number on the top, the numerator, is higher, so that must mean I'm dealing with something that's more than 1. So if I drew my number line, I'm going to put 1 a little bit over here because I know I have some fractions I'm dealing with that are a little bit more. I'm going to put 2 over here because remember, number lines go on forever and ever and ever and ever and ever. They never end. So there's always something on the other side. So what this fraction is saying is I have 3 pieces, but there's 6 of those fractions that are broken into 3 pieces. So here's 1 piece, 2 pieces, and 3 pieces. So that's 3 out of 3. But I have 6. So that means I have more than 1, remember. So break this one into 3 parts also, because that means I'm going into another whole piece. And then there's 4, 5, and 6. So that'd be 6/3. 6/3, it looks like, is the same as 2. Ooh. Let's think about this with 2 now. Give ourselves a little bit more room. Okay, so let's say that I have this number line again, but this time instead of being broken into 3 pieces, my denominator tells me it's broken into 2 pieces. I'm going to break that into 2. I'm going to break that into 2. So now I need to count. 1, 2, 3, 4. Oh, hey! If I have 4 pieces of something that was broken into 2, it's the same as 2 also. So that one is also true. All right, let me go over to our next example. And it's not coming over here. Let me see what's going on. Let's exit the drawing, leave it out. There we go. All right, so 2 or more fractions. So each diagram represents 1 whole. So this whole strip right here represents 1 whole. It says write 2 or more fractions that are the shaded part of the diagram represents. Be prepared to explain your reasoning. So there's a lot of math words in here. All this means is that you need to look at this fraction and try to find some other fractions that you could write. So what we talked about in class is this one, if we were to count it, we would have 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces. And there's 2 that are colored in. So that's one way we could write that. Ooh, that's a 2. Believe it or not, that is a 2. Writing with my mouse pad is not my strong suit some days. So believe it or not, there's another way we could break apart this fraction. It's the same kind of idea of giving someone 5/10. We've talked about that is a half because we know that half of 10 is 5, so that's a half. So let me just look and see. If I counted by 2s, 2, 4, another 2, ooh, and another 2. Oh, hey, I could group them by 2s and cut it into 4 pieces instead of cutting it into 8 pieces. So that would make it 1/4. So that's another way we could break apart this fraction. It'd be silly if I knew I was going to give you that chunk, and unless you were really worried about being messy or whatever, I could just cut this into 4 pieces, and still you would have the same chunk of that whole. Okay, now this one, they broke it into 1, 2, 3, 4, 5, 6 pieces. We have 2 6s. Ah! Sometimes it doesn't quite release as I move. Okay, so same thing. If I'm thinking about making this less cuts, let's say it's really hard to cut, and I really don't want to cut through it as much as I can, and I know I'm going to give you this chunk of it, you're going to get 2 pieces. I could easily break this into 1, 2, 3 parts, because these 2 pieces, 1/6 plus 1/6, that's equal to 1/3. If we had that fraction poster up right now, that's what it would show, that we could fit 2 6s into 1/3. So another name for this fraction is 1/3. Okay, this one, You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm running out of room. And then 2 of them are colored in. Ooh. So I'm noticing a pattern here. Whenever I have a number higher than 1 on the top for a numerator, and I have a number on the bottom for a denominator that you can count by 2's to get to, it's a multiple of it, I can make it so that I'm grouping them into groups of 2. I can count by 2's to get to 10, so that means I could put 2's into chunks instead of having to make 10 cuts. I can make less cuts. So that looks like 1, 2, 3, 4, 5. So I could give you 1/5 and not have to cut so much. Like maybe it's a really thick chocolate bar. Whew. Sometimes those are hard to cut. All right, this last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whew, 12. Ooh, and they shaded in a lot of pieces this time. Oops. Like I said, not always easy. 1, 2, 3, 4, 5, 6, 7, 8. Ooh. Now something I'm noticing here. I'm thinking of my multiples. I can count by 2's, so I could group them into 2's. But I'm also looking at both numbers, and I'm thinking when I count by 4's, I go to 8, and I also get to 12. So I'm going to save myself a little bit of work, and I'm going to think about grouping them into fourths. Might make things a little bit easier. Well, not fourths, grouping them into 4 pieces each. Ooh, when I do that, that makes it into even pieces. It makes it into a 1, 2, 3. It makes it into thirds. So I could give you 2 thirds instead of having to go through all the trouble of giving you 8 12s. 8 12s, yeah, that works good. Okay, so now we come upon writing 2 or more fractions that the point on the number line represents. So the straightforward answer for this one, there's a straightforward one, there's one that you have to do a little extra thinking on, is 1, 2, 3, 4, okay, 5. So we're breaking this into fifths. So this would be 1, this would be 2/5. We could break this number line into more pieces and have an equivalent fraction with more pieces, but we're cutting the number line into more pieces too. So what we did is we decided we were going to break each piece into another piece. There's a shortcut that I'm going to show you in just a minute, instead of having to do all this extra thing. Okay, so this would make it into tenths, right? Because we cut each piece into another piece. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So now that they're into tenths, I need to figure out how many pieces I need to give you if I promised you that chunk of the number line or candy bar or whatever we're breaking up into. So 1, 2, 3, 4. That would be 4/10. Whether it's broken into 4 pieces or it's broken into 2 pieces, I'm still giving you that same part of the number line. Okay, we would do the same for this one. We would find where that fraction is. Now this one was a little trickier because they didn't tell us where 1 was. So we had to kind of figure out if that's 1/4, then that means there's 4 pieces to make 1. 1, 2, 3, 4. So this would be 1 right here. So then we were able to figure out that this was 3/4. And then we did the same thing. We broke up the number line a little bit more into other pieces. All right, so let me show you the shortcut. So instead of having to cut the number line into all these little pieces, especially once you get into higher numbers, it gets a little crazy. So let's say I wanted to find the equivalent fraction of 3/4. What you can do is you can multiply the top number and the bottom number by the same number to find out if it's equivalent. If I multiply them by 1, they would still be 3/4. If I multiplied it by 2, let me show you the 1. So that would still be 3/4, right? 3 times 1 equals 3. 4 times 1 equals 4. But if I multiplied it by, let's say, 2, that would be 3 times 2 equals 6. And 4 times 2 equals 8. So that's how you could find an equivalent fraction an easier way. I'm going to stop right there. Please let me know if you have more questions, and I will send you a video. Bye.